Alright, in this video we're going to take a look at the periodic motion of a pendulum. So what we see with a pendulum, and let's take a quick look at the picture. If we were to leave it at its equilibrium position, so equilibrium, remember, is the lowest point, and pull it back to position A, its maximum height, and then to let it go. It would swing down towards equilibrium, speeding up, then it would slow down from the restoring force that's back towards equilibrium, till it reaches its max height, speed up back towards equilibrium, and come back to where it started. So one full oscillation is from A to C back to A. So completing one full cycle. If I started at C, it would be from C down to A back to C. If I wanted to look at it from B, let's say I bring it back to A, I let it go, and it crosses past B, it would be B up to C, back to B, back to A, and then back to B. So it would be back to equilibrium, but in the direction that it was moving. So one full cycle. What is the period of the pendulum? Well, this is the time for one full oscillation. And it should be the same regardless of what reference point you choose. We measure this in standard units of seconds. Okay. Now, what about frequency? So frequency and period are inherently connected for all things that oscillate. Frequency is the number of cycles or oscillations that something in periodic motion undergoes per second. Now if we look at this, standard units for a period, this is really seconds per cycle or seconds per oscillation. Right? How long does it take for one cycle, per one cycle? And this is number of cycles per 1 second. So what do you notice? These two quantities are inverse of each other. And we denote the period with a capital T. We denote frequency with little f. And so our standard units, cycles per second, sometimes are referred to as inverse seconds or 1/seconds, and they're given the name a hertz. So you ever heard of megahertz or gigahertz or anything referring to frequency? It's typically in the standard units of hertz. So period in seconds, frequency in hertz, the time for one cycle, the number of cycles per 1 second. Now how are these related? What you notice is these are inverse of one another. So a period is the inverse of the frequency, or you can write this as frequency is the inverse of the period. And this is a relationship that will hold true for all things that undergo or experience periodic oscillatory motion.